So I think the best way to start this panel is basically to introduce everyone. And I could do the introductions, but I think everyone can do a better introduction than I will. So I just want to ask everyone the following question, which is basically provide like a 1 minute overview about your product, about your rollup. Although I've already heard a lot about Ellie's already, but you can do another 1 minute 1 minute overview. And then the question is, what's the one thing that makes it really great? And what's the one thing that makes it really annoying? So like a con uh afterwards. So Harry, do you want to go first, I guess? Because you're the first on my screen.
Sure, happy to. Excited to be here. Thank you. Yeah, so I'm Harry. I'm one of the co-founders and the CTO of Off-Chain Labs, building Arbitrum Rollup. So we're building an optimistic rollup that I think we'll dig into the details, but and I'm going first. So I mean, rollups in general, we move execution off chain to not weigh Ethereum down. And then we just sort of, in some way prove the correctness of what happened off chain to the on chain mechanism. And I'm sure we'll dig into the details. There's optimistic, there's ZK. For our optimistic rollup, I think kind of the most exciting thing there is generalized EVM support. Generalized EVM support and kind of the prove the fact that the technology is just kind of out there. We've had our public testnet for I think 6 months now. We'll be opening up to users soon for our mainnet, which is kind of currently in a closed developer beta. And so yeah, I mean, just sort of like the fact that the technology is here and kind of can support Solidity, I think is really kind of the coolest thing to me. In terms of downsides, probably of optimistic rollups generally, we have sort of this withdrawal delay. The way that we handle kind of fraud, the way that we handle kind of proving to Ethereum is via fraud proofs, and you have to provide time for those to come in, which means that kind of interaction between the rollup chain and Ethereum has kind of some inefficiencies in it.
Cool. And then Liam, do you want to go next?
Yeah, sure. So my name's Lane. I'm one of the co-founders of Connext, and we do state channel systems. State channels are, one of the oldest scaling technologies that was proposed for the blockchain world. So it's been around for a while. It's most successful on Bitcoin with the Lightning Network. It's basically two parties will put funds into what's essentially a multi-sig and transfer between each other and update the balance of that multi-sig. And all of these updates are signed. So you can layer these on top of each other and have intermediaries that forward payments between channels and kind of form a more generalized network. What's really great about that is it can happen really quickly and it's very, very, very low cost. So there's no fee per transaction within a channel. The downside is there's a fixed participant set. So, you lose a lot of the composability that is so great about Ethereum and other smart contract based blockchains.
Awesome. And then Alex, do you want to go next?
Absolutely, yes. Hi everyone, I'm Alex from Matter Labs. We're working on ZK Sync, which is the first EVM compatible ZK rollup. And the great thing about this is that it's a ZK rollup, which is a very cool scaling technology, which is probably technologically most convenient and secure thing you can have, from a theoretical perspective. And what makes it really great, it's the EVM compatibility. You can take Solidity contracts that are running on mainnet and deploy them without modifications in most cases. And the annoying thing about it is that the public testnet, it's still not open. So it's the reverse of what Harry said. It's not yet there, but it's coming very soon. So we intend to open the testnet to public within weeks from now.
Awesome. And then Ellie, I guess you can go now.
Okay, so I'll be very brief. Eli Ben Sasson from Starknet. I spoke at length. So and I said a lot of the good things about Starks and Starknet. So you asked about the annoying things. I mean, one thing I'm annoyed by is that Aviru, who should be on the panel, is not yet there. He's going to do a better job. But jokes aside, actually, there are many things that are annoying currently with Starknet. Well, there's no compiler from EVM. There are a bunch of built-ins that will make things more efficient for working with Ethereum that don't exist yet. The code for the prover is not yet source available. There's a long list of things. All I can say is that there are many things that we would like we don't have ECFFTs implemented over them yet. We don't have all fields. It's restricted to one field. Many other things that are annoying with them right now. But still, we like them.
Okay, that sounds most like engineering challenges there, mostly.
Well, yeah, lots of engineering challenges. And there are some, there are many great theoretical questions. Reducing the proof size more. I guess, let's see what else. On theoretical side, well, yeah, reducing the proof size more. But I guess other than that, we're very close to the theoretical bound. So, not so
awesome.
Much to improve.
Awesome. So just moving on. So before I get into the deep, technical questions, I just want to throw this out because I think it's really fun. Like every team here has been building for roughly 2 to 3 years, we can say, by 2017, 2018 is when I seen a lot of these projects start to emerge. And that was a very different world than we're in now. Blockchain scalability via layer 2, we seemed like a pipe dream. Everyone thought state channels would be used for dApps and we'd be playing, I don't know, chess or tic-tac-toe in the channels. And Battleship, yeah, I was trying not to say Battleship, and rollups didn't exist. It was all about Plasma. We were all complaining about data availability. The Plasma paper was not really readable. I tried to read it, but it was just like the Lightning paper, and that wasn't readable. So a lot has changed over the past 3 years. I just want to throw this question out to whoever wants to answer it. What do you think has changed for your project over the past 3 years? How have you dealt with this transition of all these crazy ideas coming out? So whoever wants to take it, just go ahead, Liam.
Yeah, I'll go first because we've been working on the same project or same technology for the last few years. Although I'm pretty sure Arbitrum and Eli have as well, and ZK Stark has as well. But excuse me. It was really rough. Everybody did think that channels would be great and you'd be able to do all this complex logic in channels. And it turns out that's actually just not that useful and actually a lot harder than it seems to implement this kind of complex, turn-based logic is kind of a pain because what happens if somebody just goes offline? That's always an open question for channels. And we were actually, us personally, we were in the middle of a fundraising round when optimistic rollups started to take off. And I think somebody had a demo available and we tried it and we're immediately just like, oh my God, this is clearly just so much better for so many of the things that you like to do with Ethereum. So for us, it was really more of a transitioning from being the chosen scaling solution to okay, well, there are other things that will be problematic when we enter into this cross-chain world. And that's really where channels have kind of hit the stride, is transferring liquidity between all of these rollups. But yeah, it was a bit of a rocky road there for a while when all of that started to come out. But really, the reason why channels take off so much in Bitcoin is because there's not as much that you can do. You can do it, just for everybody out there, you can do it. Most people don't. And it's a lot easier to build those types of things on Ethereum. So rollups of all kinds really allow that complex logic to take place in much easier fashion.
Yeah, just to comment on the Lightning Network, I think people, I always describe it as a routing network. It's not very good for payments. And we sort of see that now, a lot of users just use custodial wallets because, as a user, you just don't want to deal with channels. You just want to send value across the internet.
Yeah.
So, yeah, so we'll get to the channels very soon anyway. There's a section dedicated to that. Does anyone else want to throw in a sort of how they've experienced the past 3 years?
Yeah, we have a pretty interesting one, which is kind of we had a big pivot kind of around, I think, a year and a half ago now, which is that up until that point, kind of we had been doing sort of application specific rollups. So let's apply, let's have a rollup for kind of some specific application. And I think probably on the ZK side, there's been a probably similar movement towards, towards from kind of application specific to generalized. just in that like kind of composability being such a kind of key and important part of Ethereum, that sort of the push towards composability is something that kind of everybody has to follow. But on the technology side, it creates a lot of kind of complexity, and there's a lot of kind of hard questions that you need to deal with as you kind of like move into that. So I mean, I think it made a lot of sense for the technology to start with kind of much more limited goals and then become sort of more expansive as we've gone.
Awesome. So yeah, we can move on to the next section then. So I just wanted to get some nice feelings around that. So what I want to start off with is mostly focusing on the roll ups, then we're going to move on to the channels, because like how they interconnect there. And the first one is mostly around so as I mentioned during my talk, what's exciting about these layer 2 protocols is that there's a bridge contract, and the bridge contract has full custody of the funds, and it has to be convinced that everything is well on the layer 2 system. And transactions aren't really finalized until the bridge contract's aware of it and is convinced that, yep, that is the final order of transactions. So this brings me to the fast path, the fast path of the sequencer and how we're going to interact with the sequencer. And really, I just want to get an idea of, let's just say I'm a user. I'm on your platform. Maybe I'm performing a swap. I'm playing fantasy football. I'm doing something where I'm interacting with the sequencer. How can the user be convinced before any data hits the layer 1 blockchain that if I give you a transaction, it's going to be executed the way I expect? Like what's your current plans for that and your long-term view for that? Maybe Alex, you want to go first, because just to give the floor to.
Sure. Yeah. So we actually wrote about this in the very first blog post introducing ZK Sync. And I just want to add to the previous question about our experience. I think it's interesting that in this space, every type of project has influenced everyone else and has pushed everyone else to the boundaries. So like the very idea of this centralized sequencer with instant confirmations comes from the fact that the channels are instant and so like user friendly, because you can just like do one click and transaction executes. So this was, like initially when people started working on roll-ups, there were ideas of decentralized roll-ups where everyone can submit the proofs independently and like make it completely free and permissionless to everyone with like and the idea of sequencer was not even there. And then everyone saw, okay, the user experience will suffer compared to this other option. So let's build something. Let's just imagine what can be done. And then the centralized sequencer was born, and with this demo by Optimism team back at I think at AdCon, with like instant confirmations. And similarly with ZK, like with optimistic rollup starting building the generalized EVM compatible scaling solutions, we looked at that and thought, well, there must be a way to do a ZK version of it, and we built that. But yeah, back to the original post, we were thinking about the convenience and economic guarantees, and we introduced this idea of economic guarantees where the sequencer, whatever it is, centralized or decentralized, maybe with some low latency consensus or whatnot, can provide you with a receipt which entails some guarantee that the transaction is going to be included in the next block. And then you can go on and retrieve it if it was not included. And this way, like, the double spend is still possible, but it's very unlikely because only a fraction of the funds will be in flight at any given point of time. And it can be much less than the security deposit or some slashable stake by the operators of the rollup that can be used to compensate the user, and part of it can be burned to prevent malicious attacks. So we are thinking about this way. We think that initially it's not really important because the reputation of the sequencer will play a role. And like if you're sending $20 transaction, you're probably gonna trust them because their reputation is a lot more valuable.
Yeah.
And if you're gonna send a $1 million transaction, you will still wait for the checkpoint on Ethereum and for the final verification. Yeah.
Okay, cool. And then maybe Ellie or Avihu, do you want to talk about that? So the questions mostly, how you doing? The questions mostly like on Starkware, because I know Starkware has StarkX, and now you're gonna have StarkNet.
Right.
And I do have a question about StarkNet, but we can just talk about either right now. Like,
Yeah, it's
so
interesting because like some of the concept, I think the two things that comes to mind is the first one, what Alex mentioned about finality of transaction with a centralized sequencer is actually something that we wrote about in the context of payments. I think it's something that we wrote a while ago. It was an article named When Lightning Starts. And it's the same concept where the sequencer signs a receipt and there is an amount per user that is locked in an external contract and the user can claim it. And the idea is that every time that the sequencer submit all the proofs, then this total number of commitments to users is being cleared, and therefore it's pretty capital efficient. The other thing that comes to mind in this context of fast path is something that we do with, for example, fast withdrawals, where the user asks for an operation, but he signed on the operation condition to some other operation to happen. And then you can use this kind of mechanism to introduce very fast operations by the operator where the user doesn't risk anything, because if the condition never happened, then the user transaction won't be executed. So that's another kind, I guess, of fast path that you can take.
okay, awesome. And then Harry, do you want to answer how Arbitrum deals with it? Because I have another question after this, so it'll relate to everything.
Yeah, I mean, I don't have too much to add here, since I think, everybody's, design. I think the design space is kind of pretty similar on the ZK side and the optimistic side. I guess the only sort of like the only sort of interesting thing to add here is that I think that kind of, so everything, you're moving through different trust models. You have kind of the point where the sequencer, where the sequencer has the transaction, it's generated an off-chain commitment, and kind of your guarantee is from slashing. And then you have the point where the sequencer has actually collected a batch of transactions, posted that batch on chain, and now you no longer need to trust the sequencer at all. And so I think kind of one interesting, and I think there's some kind of going to be differences in kind of different people's approaches, is basically sort of how quickly it goes from the sequencer having the transaction to posting the transaction on chain. Because I think that for the $20 transactions it doesn't really matter, but for kind of plenty of applications I think that does matter. And I think that's kind of like it's the sooner your transaction gets posted, the less time you need to spend worrying about the sequencer becoming malicious, and the lower value the sequencer actually, the lower the value of the sequencer attacking will be, essentially. If it can only sort of control the ordering of the last 5 minutes of transactions in an attack scenario, then it's a lot kind of more bounded compared to if it can control the last, let's say, 2 hours of transactions.
Awesome. So, okay, that sort of winds me straight into my next question then. So basically it sounds like everyone takes a transaction, they give a receipt to the user, and they may or may not get slashed depending on that gets implemented. But one interesting quirk between the optimistic rollups and the ZK rollups that I've noticed is there's a difference when the sequencer, takes the transactions, they create their batch, the type of data that's sent to Ethereum can be very different. So in optimistic rollups, you would tend to send the transaction data that may include the signature, the value, the data that's being executed. Where for these ZK rollups, although I need to confirm a ZK sync, so you can answer the question, answer the second one, Alex. You don't necessarily need to post why this transaction is valid. You just need to post how to update the database. So what you could post is a state diff. So here's the key value pair, here's the state diff, just update the value, and that's how you update your database. And that's because the proof itself basically says why this is a valid update. Now, my understanding is that for the ZK rollups, they take advantage of that, being able to take 100 transactions and compress it into a single status update or database update. It's going to take a while until there's final. The longer you wait, the more you can save costs, but then the longer it's not being finalized on Ethereum. So this is just for the ZK rollup. So I guess I'll start with Alex. Does ZK sync? Do they post? Is that currently posting transaction data, or is it posting state diffs? And if it's posting state diffs, how do you feel about the time to be finalized and balancing saving costs of what you're posting?
So for ZK Sync version 2, we will post the state diffs, but I don't really get so I don't see the connection between what we post on chain and the finality time, because
so what,
no matter, so like doesn't matter what you post, as long as you don't see anything, you don't have any data, right? So so maybe I'm.
So, okay, so what I'm thinking of is, as the sequencer, I collect 100, the more transactions coming in, the more I can compress those transactions and post, up. So if I get like 1,000 Oracle updates, then I just have to post one update, one state update for that on Ethereum. So the longer that I wait to post a block, the more I'm saving over time that I'm posting to Ethereum. And then the other side of that was going to be my next question. The longer you wait, the more opportunity there is for MEV, because you have more transactions that you could reorder. And just your thoughts around that, really.
Well, how we think about it in ZK Sync version 2 is there is going to be a consensus at layer 2, which is much faster, and it can be much faster because it doesn't have the same decentralization requirements as the consensus at layer 1. Because the validators cannot do anything wrong without the user's permission. So the only thing they can do is MEV and double spends and reordering, and it's just essentially like rewriting the blocks, just like complete rewrite. So the stake of the validators, which is locked in this consensus, should be sufficient to prevent those types of attacks. So it can be much less than the layer 1, because it's not serving the purposes of the ultimate security, but it should be enough to prevent this intermediate kind of attacks for a prolonged period of time, let's say for 1 hour. And I think that 1 hour will be more than sufficient to collect a lot of like very long batch, which will justify the Stark proof or even the Stark proof, and will contain enough data so that the efficiencies of the state diffs are also visible. And like just like you said, like the intermediate transactions are not published and so on.
Okay, cool. So I mean, that's one. So that is one. I mean, I'll just ask this as well. So as you have these sequencers, do you plan to post the pending transactions that are going to be finalized, or will it just be kept private amongst the consensus protocol? I mean, like as a user, could I verify transactions that haven't yet been finalized on the network?
You will be able to, but you will need the requirements for running hardware will be higher.
Okay.
So it will be comparable. Like, can you verify transactions on these fast side chains that we have, like Binance Chain and Polygon? Yeah. Probably yes, or Solana for that matter. Probably yes, but you need like a really powerful machine if the throughput is high. It will be similar here.
Okay, well, I'll move the question with Avihu now. So Avihu, what do you think about it? So the question's mostly,
I think.
Oh, go ahead.
I think that something that is often overlooked, and this is basically there are two types of saving that can happen in ZK rollup that matters and should be considered here. One is actually mentioned in the question. This is the data saving. So if you need to post less data, and it's not just about state diffs, right? It's about every witness in every application. It can be Oracle price. It can be a range proof, like in private games, or a mixer. It can be all kind of variety of witness data that today clients need to read to verify the state. And with ZK rollup, they just don't need to read it. It's not just about the layer 1 cost. It's about how much data clients need to read to verify the state. Clients don't need to read it. It also doesn't need to be posted on layer 1. So it's like saving in the reading and on putting data on an expensive shared resource that layer 1 is. And the other resource is the computation, right? Because ZK rollup not only saves you the need to redistribute witness, it also saves you as a user or a client that wants to verify the latest state,
they need to re-execute each and every computation in every transaction. Today on Ethereum, you don't see much of it exist because applications are not computation heavy, they're not data heavy because Ethereum doesn't allow it. But you would want to write the next dark forest or a better DYDX using more computation and more data. And that's exactly what clients will be able to verify faster by faster, I mean, be able to know the latest state of those applications faster in ZK rollup than what exists today or an optimistic rollup, because they're saving this data of witnesses and computation, recomputation. That's I think the most important two things to understand.
Awesome. And that's one of the things I wanted to get out of this panel was to really highlight that data type difference. I think it's something that's very much overlooked, but it's actually quite a huge difference between the two approaches. And so I'll go off to Harry now because I feel like you've been left out of it. And then I'll get on the lane soon because I feel like you're both being left out of it. So Harry, so in optimistic rollups, it seems like the complete opposite. As in you do have to post most of the transaction data, and I hear you can save some of the data that you have to post. But because you're not trying to save on the data cost, you can just post them to Ethereum very quickly. I remember using the test net and it was sort of instantly sending the block to Ethereum for me. So like, what are your thoughts around that then? I mean, it's sort of like this weird trade-off.
Yeah, I mean, personally, you know, I really like kind of the fact that with optimistic rollups running at scale, kind of batches will be able to be posted, you know, quite rapidly. And so essentially sort of the amount of time that the sequencer has to be trusted or that sort of any sort of like other consensus mechanism needs to be trusted is going to be quite small, essentially because kind of the fixed costs associated with batch updates are tiny. And so kind of, you know, where most of the cost is just kind of actually posting the transactions, it doesn't really matter, sort of you can post them frequently. And so I think that, like, you know, I really like that because I think that sort of like the sequencer is great from a UX perspective, but it really complicates things from a security perspective, and it causes the models to get kind of a lot wonkier than they otherwise would be. And so having it be sort of that you really don't need to worry all that much about the sequencer because the amount of time you're trusting that for is kind of quite minimal is great. And like I think this is going to come up in some important ways. So like, you know, for example, with like, you know, state channel transfers or exchange withdrawals, or, you know, I think that there's, you know, a variety of mechanisms where personally I would feel a lot more comfortable with sort of just not dealing with worrying about the sequencer or sort of, you know, however that's working, and just kind of want to have the concreteness of like what is on Ethereum that we can get a guarantee of. And so I think, you know, that's pretty nice.
Okay, well, this sort of brings me to my next question, and everyone can answer this. I just want to get everyone's thoughts. MEV, is it a business model or is it a problem for your rollup? Do you think it's going to be the thing? So why I say that is, you know, it's a problem because you're taking more money from the users, but on the other hand, it could improve UX because now there's no transaction fees. You know, if you extract money from my transaction, I don't have to pay you a fee. So, I mean, everyone, even actually, Leanne, do you want to go first? I mean, not that you're designing a rollout, but what do you think about MEV from a channel perspective?
Yeah, I mean, from a channel perspective, you know, you're mostly executing things between the two channels, the closest you can get to like.
Oh, okay. I mean, just from
MEV.
your perspective. This is your
perspective.
perspective.
From my perspective in general, I mean, I think you can do a lot of interesting things with MEV. I think it actually will be fun to see the different designs that people can come up with. It's hard for me to classify it as like a good or a bad thing. It's just simply a thing that is, you know, part inherent to the systems. I think it will be, from a user's perspective, if I'm getting funds that like would otherwise be going to my MEV, then, you know, that's great. I'll probably stick with that rollup. But on the other hand, you also want to make sure that your rollup is attracting enough sequencers. So it'll be an interesting balancing act that these projects will kind of have to find the right line between.
Yeah, and would you feel worried about deploying connects on a chain that's very like MEV positive, or is it just something you wouldn't really consider?
It's something that we haven't really considered. I don't think we would necessarily be worried about it.
Okay, cool. I mean, that's actually quite nice, like unique, like a team that's deploying on rollups in their perspective. I mean, it's a very small sample size, but okay, Harry, I mean, because you should have triggered this question, Harry. So what do you think about MEV?
Yeah, I mean, I think that minimizing it as much as possible is very valuable. I think that, like, you know, essentially because it you know, it makes the user experience a lot worse. Essentially, kind of the ways, you know, if someone's extracting value, that means other people are losing value, and that means that the system is you know, losing significant appeal to them, as opposed to, let's say, you know, funding through, you know, a flat fee, which, you know, a fee of some sort where you can, you know, you can model it, you can know, like, well, if I'm going to use the system, I will, you know, there'll be some small cost, and so all I need to do is be confident that essentially it's worth it, as opposed to with MEV, where kind of understanding it, modeling it from a user point of view is just sort of, you know, nightmarishly complicated. And you run into issues. I mean, just like, you know, with like DeFi, that, you know, people have had to wrap their head around impermanent loss, and like, is it worth using the system, you know, under these complex constraints? I think MEV is going to create a lot similar sort of like, I can't tell if it's worth interacting with the system sorts of questions. And so, you know, I think, you know, beyond the point, you know, where you can eliminate it, I think capturing it is very reasonable. I think, you know, what Flashbots is doing at Ethereum is very cool. So I think there's definitely kind of value in understanding it and trying to, like, you know, not have it, you know, fall into the worst possible hands, but wherever we can eliminate it, I think that's what we want to do.
Yeah, but what I remember is, like, I know Stephen worked on the fair ordering protocols. Is that something that Arbitrum would try to pursue then, or will they just?
Yeah, I mean, it's an area we're very interested in. Like, you know, it's you know, we don't, you know, it's hard, you know, the tech is still under development, and you know, and obviously, like, the, you know, the initial, you know, the like research area creating paper was not that long ago, and so there's, you know, I know there's iteration being done on those ideas. But I mean, it's certainly kind of the direction that we find most promising at this point, to sort of minimization.
Oh, Andrew just asked a question, or okay, I think what I'll do for the questions is I'll leave all the questions to the end, because I'm going to leave 20 minutes near the end for audience questions. So if you have any questions, just drop it in the chat, because I want to ask Alex this question as well. Alex, so with ZK Sync, I mean, you did transfers to begin with, so there's never really any MEV transfers, but then you're going to soon have the ZK EVM, where obviously there will be some form of MEV. Like, what are your thoughts around that? Do you even consider it a problem yet, or is it, what's your opinion?
I think it's worth understanding generally why MEV is evil. So like inherently evil, why we want to minimize it. I was just thinking about some good analogy. So like if you think of, I don't know, like a company which compensates its CEO for doing a good job of managing the company, and then someone comes and offers them a bribe. You know, like, you could say, like, why is it bad for the company? Like, the CEO just gets a better compensation, and so like he should be more motivated to work or whatever. But you see here instantly that the incentives of the people who pay the bribe and who get the bribe are diverging from the incentives of the other stakeholders in the system. So MEV is kind of a similar thing. So it's not just like changing the form of payment for some services from like explicit transaction fees to implicit transaction fees through the reordering, but it also changes the locus of control. Now, all of a sudden, whoever runs the sequencer, or like whoever runs the miner, is able to manipulate the transactions and not necessarily bring all of this value back to the shareholders. So like, if you think of Ethereum miners, you have like most of the transactions are mined, or most of the blocks are mined by mining pools, and these mining pools get hash power contributed by a lot of miners. Now, whoever is in charge of the mining pool controls MEV, and it's really hard to prove that was this an MEV transaction, not like you just reordered. Was it like was it from someone else? You know, like, you can always hide it and argue that it was someone else who inserted this transaction, but then the actual beneficiary is not the user and not the miner who actually contributed to the security of the system. So because of this intransparencies and changing the locus of control, I think like there is probably a more formal way to define it, what's wrong here, but intuitively it should be clear to everyone that this is a very bad thing and we want to minimize it as much as we can. And with ZK Sync, we want to call cryptography to rescue whenever possible, and we believe that it will be possible to eliminate MEV more or less completely with the use of advanced cryptography, with things like time-locked encryption in the future. In the near future, I don't think it's going to be a big problem, because with a centralized sequencer, your reputation is at stake, and if you just commit to doing no MEV, then you can statistically show it. Like you can just provide instant confirmations to the transactions of the users, and they will see that nothing else is happening. And the users who do not like what they see will just stop using your system. But we want to decentralize very rapidly, and this will be a problem, and we want to solve it with cryptography.
Awesome. So like independent verification, then a user can verify in the short term themselves. You know, they can't see other transactions, but they can see their own promises are adhered to. Just to Avihu, just quickly, what do you think about MEV? Just generally speaking for the Starkware stuff.
Yeah, I don't know if everyone been here before when we presented. So we are right now in the middle of a hackathon. I guess Ellie mentioned that. And actually, the team that I'm at, what we are doing, like what we decided to do as a project, is to use time locks and VDFs in Starknet to present a way to mitigate front running and MEV to whatever contracts and application that choose to use it. So the basic idea that we implemented was that every transaction that the user sent, before they send it, they encrypt it, and they encrypt it using symmetric encryption, and they take the seed and run the seed through a time lock where they compute the easy side of it, and then they send the result to a smart contract in Starknet. Now, the smart contract only know of the order of the transaction that he receives from the sequencer, but the sequencer and in the system really can't see what's in the transaction except of the user. And the time lock is long enough. It's actually longer than the finality of the system. So in most of the cases, or the user can expect that his transaction will be committed, like the order of transaction will be committed before it is known what's in the transactions. And then what we are doing is that everyone in the system can see which transactions and VDFs were published, and can take any, can take the most, like the oldest transactions that haven't been decrypted yet, take the key that went through a time lock, recompute the time lock, prove it with a ZK rollup with Starknet, prove that the opening of the key is actually the key that they provided, and basically open the transaction and call the contract.
Well, just to summarize that, so it sounds like the user basically like encrypts their transaction somehow, they give it to the sequencer, it'll be finalized on the network, and then it gets sort of decrypted eventually, so the sequencer never gets to see the content of the transaction. They just order it. Right.
And I think, first of all, the times that it takes to run, the numbers, it seems like feasible. The time that the user spend or that the revealer spend to open a transaction is reasonable as well. And at the same time, you can use it, you can actually use it not just for applications on Starknet, because this is something that is pretty heavy to run on Ethereum, but if you run it on Starknet, you can use it to actually generate a sequence of transactions also for layer 1 application. So there is no reason that this have to work just with layer 2. You can, for example, deploy tomorrow, and maybe we'll manage to do it at some point, to deploy a version of Uniswap where that only accept transactions that were queued in using this layer 2 contract. And the contract will actually send the queue once the VDF was computed and the key was used to decrypt the message. So it's something that you can use also to handle MEV on layer 1 today. So I think it's pretty cool.
That's pretty cool. Yeah. So I'm just going to move on quickly to some questions about channels, and then we're going to take questions from the audience because I can see them all. There's a lot of questions queuing up now. So just to set the context, as we can see here, we have 3 different rollup providers, which are basically like brand new blockchain networks that they're all building. And so now we're going to enter this multi-chain world. And this is why I was really excited to get Connects on, to get Leon on, because payment channels for a very long time have had very little use cases. Even the Lightning Network has struggled predominantly for the past 3 years. Capacity is going up now because, El Salvador, etc. But, it's a struggle, and I think people would admit that. But Connects is pumping a couple of $1 million per day through their channels. And so I want to ask Leon, why have you got usage? What did you do? What is it doing now?
Well, it actually wasn't us. It was Matic and BSC. Yeah, the main, the new spot for channels I mentioned at the beginning that we had to kind of find where we fit into this new ecosystem and how channels could actually help scale things, because they clearly weren't going to work for the majority of use cases that people wanted to execute on Ethereum. That's just not going to be what it's designed for. We couldn't even get Battleship working. There's no way we're going to get DeFi in channels. So we ended up saying, okay, but a new problem here is that all of these rollups will have their own bridge contracts, and most of them, well, the optimistic ones will have a longer withdrawal window, and all of them will have to go through L1 if you want to get your funds between these contracts. And that's kind of a huge pain, especially for users. So channels are really great because of their instant finality. You can actually have somebody provide liquidity on a destination chain and be willing to accept your funds on whichever origin chain that you're starting with. So we actually do this live in Cross-Pollinate, which is what has all this usage with different stable coins on different side chains. So if I'm searching for yield across all the chains, and some really great projects are winding down on BSC, and that some really great ones are starting up on Matic, I want to get my liquidity there as quickly as possible, and I don't want to pay any fees because generally nobody wants to pay fees. So I would have a channel on both chains, find a router who is willing to provide my USDC, or more realistically USDT on Matic, and is willing to accept USDT on Binance. And then you just create a payment that goes through both channels, and you're able to instantly transfer your funds. And this can work for any kind of EVM compatible rollup without introducing any additional trust assumptions or people who are verifying that this has actually happened. It's just the same people who are in the channel, and then if there's disputes there, the same security as the base chains.
That's pretty cool.
Yeah.
So just I got 2 questions here. Then is one, what's the peak volume you've seen then through these channels in a day? And 2, channels have capacity limits. It's sort of like a rope with little balls on them, and you're going back and forth like this. How have you felt? How's that capacity limit impacted your service, or has it impacted it?
Capacity limit hasn't really impacted it at all whatsoever. The main impediments to growth have been actually the infrastructure that's available for these different chains. So BSC, it's a lot harder to be a node for and validate all the transactions for. So you actually see that when you're using remote RPC providers, which everything will need. And so when you're not able to validate that, a deposit has happened to your channel on chain, or the withdrawal has gone through, then that creates a huge problem. And we haven't even touched the channel capacity limitations at all. The peak volume that we saw was, I'm not sure how it worked out per day, but weekly it was around 40 million. So Jesus. Yeah, quite a bit. But yeah, the interesting thing about that was we've never put more than 1.5 million of collateral in the router at any time. So that 40 million
1.5 million.
Yeah. So a lot of people were worried about capital inefficiencies, but that just turns out it wasn't the case here.
Incredible. That's a huge collateral in a hot wallet. That's
yeah.
No, that's awesome though. So I just wanted to highlight that. So basically channels are clearly solving the problem for moving funds across different blockchains, and it sounds like the UX is fairly straightforward for that.
Yeah, we obfuscate a lot, so it just looks like a simple deposit on their end, and then it magically appears. But there's a fair amount going on under the hood. But the UX seems to be pretty nice when it works.
Awesome. Awesome.
Yeah.
So what I'm going to do now is, because I have 13 minutes left, and I have people are dumping a lot of questions in now. So I'm just going to ask the question, and then anyone can just shout out and answer it. So I don't want to be picking people for this. So the first one's from Andrew, was is MEV a market failure, or does it have a good market solution? Like all else equal, users will get better trades for the same liquidity support in a system that provides MEV fairness. So whoever wants to answer that.
Don't everybody go at once.
Yeah.
I mean, I'd say that, if there's the problem, one big problem is it lack of information. That, like, it's a very low information market because people don't have a lot of insight into like what's going on behind the scenes. And so, like, to the degree where there's market failure, it's probably due to like overall lack of information.
Any other takes, or should I move on to the next
Yeah.
question?
I mean, all I'll say about it is, like, there's some benefits that the user will get outside of trades in a system where it's like MEV maximized, and that's from like not having to pay fees, because the miners get fees in other ways. So it's not just like there's only one dimension of positive user experiences that MEV impacts. So it's kind of like a more dynamic equilibrium than I think a lot of people give it credit for.
Awesome. So the next question is from Sergey. Although I feel like we've already answered this question, but I'll ask it anyway because it's here. It seems that rollups constantly post data as part of a normal operation, whereas in channels, you only interact with the L1, the open or close your, handle disputes. So does that mean channels have a significant scalability advantage compared to rollups? So maybe Lynn, you want to take this, and then I can see Harry jumping in already. But
yeah, I mean, it depends on what you want to do, right? Like for payments, like just payments between a couple people, channels are great. Like if micropayments ever become a real thing and like the decentralized web, it will be really hard to touch channels on that. I just think that's not what most people want to do. And so most of the time you do need some type of on-chain data availability to make the applications that people want to, or like actions people want to do, workable.
I was just going to say yes.
Alex, Avihu, do you have any comments on that, or? No, okay, that's fine.
I was going to say yes.
Okay, so I think the next one's actually a really good question. So I sort of made a joke earlier that rollups are sort of kicking the can down the road. So you're basically moving computation to a different network, but then this different network is going to have scalability, limitations at some point. And so the question here is, what's the state size management techniques being explored for rollups full nodes? So obviously, there's this really funny meme on the internet. It's sort of like of Scooby-Doo, the guy from Scooby-Doo. The guy's mask is like layer 2. They take the mask off and it's Go Ethereum under the hood. So the joke here is really going to be how are you guys dealing with state size management if the state starts to explode? Anyone who wants to take the floor for that?
So, well, as I mentioned earlier, you can have much higher requirements on the hardware of the sequencer providers or this layer 2 consensus network in general than you have at layer 1, because at layer 1 you have to optimize for the full nodes to be runnable on consumer hardware. I think it's also the case for optimistic rollups. You want it like as much as possible to actually have a lot of validators who can run it in the most decentralized fashion. But for ZK rollups, for example, it doesn't really matter because the security only depends eventually on the proofs, and on the data which is published through the main network. So you can have just a lot more processing power parallelizable processing power, a lot more memory requirements, and so on and so on. You can just load everything into memory, and you can do sophisticated things to build transaction graphs and see what can be done in parallel, and so on and so on. And then provide only the final state and the final proof to the underlying layer one. So this is how we achieve the breakthrough in scaling at layer two.
If I may add on that, so it really depends, just to continue Alex's words, it really depends what you define as a full node. If your definition of a full node is, I want as a client to be able to verify the latest state of the system or part of the system without relying on too many new trust assumptions, then I'm like in ZK, it's very unique. The unique case is that if someone handles you the part of the state that you care about, you can verify it against a fairly fresh commitment to the state. So if you run an Ethereum node and you want to know stuff about the state, in ZK Rollup, it's very easy to sync on the state by just getting it and verifying it versus a commitment. And even if you want to, from this point on, keep syncing yourself on the state, it still doesn't mean the same cost that it means on Ethereum, because you only have to update state diffs, you don't have to recompute, you don't have to re-download all blocks. So there is still a huge benefit of running a full node in ZK Rollup versus running it in layer one or other side chains or optimistic rollup. So I think there is an advantage, like an inherent advantage that the protocol offers, that the solution offers. And on top of that, yeah, of course, we want to handle storage and state as good as possible, and we have we are free to do so because we are basically building a new solution.
One thing to add on there, which is just sort of like, you know, one really nice thing that rollups provide is kind of an opportunity for parallelism. So I mean, kind of one part of kind of our future vision of sort of how things will develop is that kind of there will be, you know, multiple probably sort of application domain defined rollup chains. And so like, you know, for example, kind of Reddit just announced that they were planning on kind of having their own independent Arbitrum chain that essentially kind of, we don't want to have try to have everybody clog onto a single chain long term, because essentially, you know, in order to have EVM compatibility, you can't innovate too much on kind of, you know, in order to really solve kind of the state growth issues, you have to really mess with the programming model. And so kind of, I think kind of you know, an intermediate approach of basically kind of being at a point where you can have beefier nodes, you don't need as much decentralization as Ethereum, and you can also have kind of parallelism by way of having multiple chains, gets us to, you know, a decent spot. And all of that, along with the fact that kind of rollups can move a lot faster in terms of innovation than the base chain. And so kind of rollups do provide an opportunity to really mess with kind of your programming model, with your data model. And so I think that's kind of an area where there's going to be a lot of sort of innovation over the next bunch of years.
Awesome. So I'm going to ask one more question, and then I'm going to ask 2 more questions, but one more from the audience, then one to finish up with. So the next question is going to be, and I think this is more like a philosophy point, maybe it's by moving the applications to layer 2, are we going to deprioritize censorship resistance narrative of blockchains? You know, so we're all using these new rollup blockchains. Do we lose any, you know, censorship resistance there? So whoever wants to take that one.
So I want to say that with the solution for front-running resistance, you automatically get censorship resistance. So it's implementable. You can, if you can submit a transaction that no one knows what's inside it, what the content is, and you can also hide the sender and the recipient and all the details, then it will provide you a much stronger censorship resistance than what you have with the current transparent layer one.
Assuming you can hide metadata as well, yeah. I guess, you know, one question with censorship resistance is always kind of censorship resistance for how long. Like I think kind of like, you know, rollups sort of, you know, with the sequencer model in the kind of, you know, in the worst case, depending on, you know, you kind of one kind of fundamental idea that I think everybody working on rollups has, that even if kind of all of the off-chain mechanism breaks down, within some decent bounded amount of time, you should be able to use the layer one itself for censorship resistance. And that's kind of a way of maintaining the trust model. And so for Arbitrum, for example, in our current configuration, if the sequencer just blocks all traffic for, I think, 24 hours, then you can just basically push transactions in and get them processed independently of the sequencer entirely. And I think that having that sort of mechanism is critical. Short-term censorship resistance, I think it does sort of, it definitely kind of, can have some weakening effect. Although I think that a lot of the sort of decentralizing the sequencer work is going to, do a nice bit to help there. Since, even if you can hide the contents of all transactions, like Alex was saying, I mean, you could still, block all of them. And put yours in front. Like you can have your friend, you can have your friends tell you which were their transactions, and so you don't know all the others, but you can preference ones. So I mean, there's it's not perfect, but it's an area that we can iterate on, and there's a lot of things we can do.
Awesome. So this is the final question just for everyone here. Is this is a group of basically professors and PhD students. They always keep their camera off because they're all really shy. But they're very much research orientated, and I think the biggest thing they're probably asking is how can what research questions, what problems do you have that they could just go work on and fix? Let's just say you had a team of PhD students for a week. What would you make them work on to solve your biggest problem? So whoever wants to go first with that.
Yeah, I mean, for us, going across chains can lead to an imbalance of collateral. And you can do some fun things with composable AMMs to kind of create arbitrage opportunities across chains. But that has some interesting impacts. And if we could get like a team of PhD students to just help us model exactly how that would work and how that affects the optimum router returns, like how much collateral you actually have and how much is wasted, that would be sweet. That's like cool. What we're mostly interested in.
I didn't consider using MMs for that, so yeah, that's really cool.
Yeah.
One particular question that's been of interest to me is it's come up repeatedly, and I don't think there's a clear answer to this, but I'd be interested in seeing more modeling done. Is basically kind of the for optimistic rollups, kind of both. I mean, kind of all. I think all of the optimistic rollups on Ethereum today are kind of pretty much randomly using a week as their challenge threshold. So we make sure that there is a week-long period of time during which people can submit challenges, and the main reason behind that is kind of the difficulty of making censorship resistance assumptions about the layer one. And this is sort of like a thing that the Ethereum community doesn't really, I don't think, know what to do with. Basically, like, if you have this roll up with a lot of funds in it, kind of are we, and I know, our friends across the aisle and the ZK rollups, have their opinions about this, but I think that like fundamentally, like for blockchains to be useful at all, there have to be some long term. If you could censor Ethereum for a week, to me, like Ethereum's not very useful. And so like in a practical kind of behavioral standpoint, like what people should realistically think about, how people should think about these security thresholds related to synchrony assumptions, which I think show up in a lot of blockchain applications. It's kind of interesting.
Awesome. Alex, do you want to go next?
I can't really think of anything that would be easily delegatable at this point. But
improving tiny RAM.
This is a very interesting area of research. So indeed, we're working with improving generally any gadgets for Plonk or Starks would be really interesting. Yes.
Okay, that's an easy answer. Then Avihu, do you have anything to finish on, like in terms of cool research topics?
Yeah, I think there are actually a lot of things that 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 more research can definitely contribute to more to better performance. There is questions around storage, how you commit to it the best way, and then how full nodes can handle it in a very good way. I think that's an interesting question, and I don't think that there is like a simple answer there, but definitely
it's like a performance study in a way.
It's also about how do you, like, Ethereum chose to manage and commit to the state in some way, and we all learned that it has obviously benefits, but it also has a lot of caveats, and there are other ways to do it, and especially when it comes to proofs, some of those ways may be more relevant than others. So that's, I think, a topic that is worth further exploring, just to give one example.
Awesome. So I'm going to finish the panel now. Thank you very much for everyone, both presenting and attending. I know it's been a very long day, so everyone's probably, I know in Israel it's probably like 10 p.m. now for you. So it's quite late. So thank you very much for staying up.
It was a nice refreshment from the hackathon. So thank you.
Well, good luck. You still have 12 hours. Okay. So I'm going to give the floor to Andrew now. It's
rump session time.
The rump session.